our podcast Beyond Degrees, where we talk beyond the degrees. This is our fifth and last episode of our season. So, let's begin.
Before we start this conversation, sir, please introduce yourself to our audience.
Hello everyone, I am Dr. Toran Verma. I am Associate Professor in CSE Department, and before that I have completed my PhD in MTech in the same university here in CSVTU, and my graduation I have done from Allen City, Bhopal. Throughout in this journey, I have published around 100 research papers, and my overall publication is mainly based on application of advanced technology in the field of agriculture. Apart from it, I am CCNA certified, and even I have done Microsoft certified professional courses, and I have passed that GATE examinations 3 times. So these are my simple basic introductions.
That's quite an intro, sir. Sir, you have 18 years of teaching experience. How do you balance your role as a professor, researcher, and new role in TDP?
So actually, if you see the responsibility in all these three roles are unique, it's very distinct. Like as a professor, I have to take classes very seriously and to mentor the students. As a researcher, I have to give additional time or extra effort to innovate some advanced research with my scholars. As a coordinator of central superintendent, main part is what that I have to uh, complete the examination in very disciplined manner in time. And the role of TPO coordinator is what that there should be a proper communications between student and industries so that student can get better opportunities. So if you see that overall responsibilities are unique, so most important part is what that the management of time and that dedication of that particular work. So on the basis of actually I prioritize the activities on the daily basis as per the priority. I actually plan and make schedules, and accordingly I handle all these roles.
Yes.
So now comes a real question. As we know, the increasing screen times in the students has affected their attention span. So how do you, what is your teaching philosophy to keep students engaged in technical subjects?
Best part is that whatever concept is there, make it is very simple. Point one, and relate it with the simple real life applications. If whatever concept we are discussing in the class related to the technical subject, and if we relate it with the real life application with simple applications, automatically a student can understand the concept. So that is my simple teaching philosophy. Whatever complex concept is there, explain it in simple way and relate it with simple uh, life problems.
Yes. So, as a gold medalist in MTech, what habit or approaches do you think helped you achieve academic excellence?
When I was doing MTech, at that time, I never thought regarding I am just going to get the gold medal. But my schedule was fixed actually. That a fixed hours was there related to preparation of theory part. Then since we already know that in MTech we have to publish the paper and again we have to do some research activity. So a fixed slot I have prepared means related to study as well as the implementation of concept in my project, MTech projects. So that was consistent, and frankly speaking, that gold medal was just surprise for me. So whatever consistency I have maintained related to my study, actually that give me the gold medal. So a simple message is what for the student is that don't aim to a particular medal or prize actually. Your task is to apply effort seriously, honestly, and remaining part will automatically come.
Precisely. So if you had to start your research journey again from start, which area of computer science would you choose to start with?
This is really very good questions, and I am still thinking about it. And point is that I have still some time so that I can start some new research there. So my previous research was basically based on that agriculture and application of advanced technology in agriculture. But now I am just going to work, and even I have started it. I just want to merge that quantum computing and machine learning with agriculture. Point is what that whatever model we have developed related to agriculture and whatever technology we are using, so it's actually very complex in term of processing time and all that thing. The application of quantum computing, if you merge these two concepts, quantum computing and machine learning in the field of agriculture, so lots of things, especially related to that weather pattern analysis or what prediction of yields, or maybe development of fertilizers which will be disease resistant, or many options will be available due to the strength or opportunities that is available in quantum computing. So my next research, or maybe I will suggest my students, even some BTech students are working on it, that will be quantum computing, machine learning, and agriculture.
Yes, sir. Sir, you have personally published over 100 plus research paper. So, what do you think is your most impactful publication and why?
That 100 papers are there, so it's actually combined effort of my MTech scholars plus myself plus my supervisor. But two work that actually I'm really happy that I have published that two research work. One is that impact of color space and feature set in identification of plant diseases. That one actually is a review paper. But why it is very important? Because during my research, when I study the work of previous researcher, on the basis of their requirement, actually they don't care about that which color space they are using, because many color spaces are there, like RGB, XYZ, LAB, different color models are there. And another thing is what, that nobody actually taking care about that which color space is good for which particular plant, or in which condition that image capture and it will give us the better result. Always their aim was to increase the efficiency without caring about or thinking about the specific color space, that that color space is good in a neural network, or that color space giving good performance in a your fuzzy inference system or fuzzy related logics. So that first paper I have published related to it, where I analyzed it, that which particular color space is good for which type of model. It will be machine learning based model, RGB is good, or XYZ is good, or whatever color space, or it is fuzzy inference system in which model is. So that was my first paper. And the second paper, even though in second paper I have just given an idea that how we can predict the possible disease that may occur in the agriculture field. Point is that just like we heard about that weather forecasting, means in advance, we already know that what will be the possible weather for next 7 days. In the same way, is it possible to predict the diseases that may be occur, that may be happen in future? So if there will be some advanced knowledge related to the possible occurring of diseases, so definitely it will help a lot to the farmer. So in my second paper, I have just implemented one basic idea that yes, there is a possibility that with the help of a recurrent neural network, we can predict possible disease that may be happen in future on the analysis of the different weather conditions and prior historical informations. So basically in second paper, I have just given an idea so that that idea can be implemented or it can be further explored, and someday someone will able to design one model which will just forecast, just like disease forecasting with that model will done just like we do today weather forecasting. So these two are my most important research work.
Yes,
You truly have a great expertise in agriculture and technology. So, what challenges do you face when you work with images captured, agricultural images, when captured in uncontrolled environments?
Most important challenges is what that is, even if you will see that research work already done by different researchers, major challenge is what that is the non-availability of proper data set related to agriculture. And again, why it is very challengeable, since especially in India or in world, due to different weather conditions, even the pattern of disease in the agriculture, even though diseases are same, but maybe pattern will be different. So most important challenge is what that availability of data set. Even in my research work also, that's why I have personally visited agriculture field, and accordingly I have captured the data. Now, during the capturing of data, another important things that you have to take care is what the intensity of light, because it vary. It will not be constant, and whatever image you capture using your digital camera or even mobile camera, so the intensity of light actually affect the image quality, and that image quality actually which you are going to use in your model, and before that you have to extract the features. So automatically whatever image quality is there, it will affect your feature extraction, and feature extractions part will affect the performance of your model. So important part is that how we are going to handle that light emitting or intensity of sunlight during capturing of images. And second is what that availability of uncontrolled data set. Because if data set is controlled and if you have designed a model, so in control manner, it will give you the very good efficiency. But practically when you are going to apply it in the field, automatically the performance of model is decreases there. So that is very, very challenging related to data set.
So since you are improving on the last model, so what are the main limitations of the current plant disease recognition systems you have faced?
Major limitations is what that with current model that is already available, and I don't say that researchers are not doing well. Lots of models are already developed. But issue is what that maximum model is developed on the basis of that constrained environment, means controlled environment. So just we have discussed that model is giving very good accuracy or performance at the laboratory level. But when we apply same model in the real field, automatically the performance decreases because there the environment is totally uncontrolled. Second thing is what that theoretically, whatever model we have implemented here, when we go to implement at the field level, farmers are not so much technological advanced. So for farmer, it is not user friendly. You need experts actually to implement that model. So that is the point that means the challenge will be what that you have to design a model which should be which should give accurate result, as well as it should be user friendly so that it can be used by the farmers.
There is a great difference between laboratory environment and the actual environment, precisely. So, what do you think? The transfer learning in CNN could outperform the traditional ML methods when applied with the agricultural images datasets?
Definitely. Definitely, it can outperform that transformation learning. It can outperform your traditional model. Reason is what? That in traditional model, obviously we need a feature. Okay, and in traditional model, whatever features are extracted, it is actually low level features. Means it will be intensity level features generally extracted by analyzing the pixels of whatever input image you have taken there. When we talk about transformation learning, so actually the feature extractions process that done, actually it happen in multiple levels. It extract low level as well as like texture and shape feature is also extracted by your transfer learning model. Now second point is what that transfer learning, that model has been already learned. Lots of informations, parameters are already defined initially, and you have to just tune it according to the your requirement. So since point is that this model, your transfer learning model, is capable to learn lots of features from your input images. So it will be, your model will be more intelligent, and your traditional approach actually learn only low level features. So it will not able to properly recognize disease as comparison to your transfer learning model.
Yes. So that was an quite an insightful answer. Sir, I have one more question. Can you explain the trade-off between accuracy and computational efficiency in plant disease detection models?
Again, it is a major challenge today. So we have already discussed that we heard about lots of technologies like that convolutional neural network, and again all that recurrent and CNN is there, and with different ensemble method we have already developed. And at the laboratory level, these all models giving very good efficiency, up to 99, even 99.99% efficiencies during recognitions of any plant diseases. But point is that these all require lots of complex resources, including GPU processor. So at the laboratory level, performance is really good. But when we go for the implementation of same concept at the field level to support or to help the farmer, so that availability of resources up to that level is not possible at present. So point is that miss accuracy is high at present, but field implementation is very low. Some traditional approach are there where we compromise the accuracy, but at the field level implementation, it is easy and less costly. So actually we have to maintain the balance between these two. Miss overall aim should be that model should be less complex, should give better accuracy, and should process very fast at the field level. So that actually we have to maintain it. Means accuracy should be enhanced, and the complexity of your model should be reduced so that it can be implemented at the field level very easily.
Do you like explaining your research work to non-technical people? And if yes, how do you explain to them in a simplified manner?
Again, if I will not able to explain my research to the society, then it's useless actually, by getting simply degree and nothing else. Because whatever research actually we do, the purpose of this research is to contribute some way in the form of knowledge so that it can help the society. So yes, I like to share my research. And again, I don't talk like uh, advanced machine learning or convolutional neural network will help you to identify this disease. I try to explain it like uh, in a gathering where lots of public is there, and our eyes try to search our individual friends. We want to identify that which friend actually come here to attend that gathering. So my overall research is actually based on it, that identification of diseases like this, that in a group of people actually you identify your friend, that he is Mr. X, he is Mr. Y. In the same way, lots of diseases are possible, and with the help of the analyzing of plant pictures, actually we categorize which particular disease actually occurred on that particular plant. So instead of using that technical jargon, different type of complex terminologies, I actually explain my research in very simple way.
Sir, as an experienced person and a member in a TPD, so what advice do you give students who want to start a tech-based startup but lack resources?
Okay, so again, and always this issue appear in a maximum colleges or university. So if you see the history of startups, one that is already famous or very successful, so they started with a basic idea with very limited resources. Whatever open sources are there, are free software, or maybe support given by the government agencies. So if you have limited resources, try to use these resources which are freely available. And again, don't wait for a very big resources and only after that you are able to implement it. point is that just you have to implement one prototype model, and if that prototype model is successfully implemented or executed, then definitely you are going to get the opportunities of remaining availability of resources. So again, that is my simple suggestions, that don't wait for a lot of resources. Whatever free resources are available, as well as whatever government facilities are available, your first aim should be design or implement a prototype model which is actually helpful for the society. So definitely you are going to get the success.
So start with whatever you have instead of waiting for some miracle to happen. So next we looking at your 18 plus years teaching experience, sir, what's your most rewarding classroom moment till date?
So best moment whenever and always it will happen. So whenever we deliver our lectures, at that time, definitely even every teacher actually understand that whatever explained, that particular student are able to understand it or not. Actually, that one what we call it spark actually happen in the eyes of the students. So definitely, if a student understand your concept, whatever you have explained in that particular class, and if you see on the face of the student, means that will be the best reward. Means it give you the internal satisfaction that whatever I have delivered, my students are capable to capture it. And another thing is what that just like just previous semester that in senior batch, they come for a minor project idea and finally they implement it, and at the end even I was not expected, and they were able to publish paper on that minor project in very good journal. So I have just given the idea, but my student explored it in upper level even which I have not thought about it, and finally they come with a better outcome. So I have just shared some knowledge, but they have done indirectly some research, and successful research they have done. So these are some parameters actually for a faculty member to evaluate, or actually that make happy.
Yes. Sir, as AI age is coming, sir, do you think AI tools like ChatGPT should integrate with the classroom or kept separate?
Yeah, actually, yeah, we have to do it. Reason is what actually, but not in that way that entire dependency should be there. Because if you see that type of AI tools and if you use it, so it is very that will help you to explain some concept in better way. If you want to show some immediate examples for any particular concept, it will able to generate it. But yes, complete dependency should not be there. And why we have to use it? Because almost all industries are now taking to help from that AI tools. So students should be familiar with that tools, but they should not be completely dependent. And teachers can use it to make their lecture more interactive with the students. So definitely we have to merge that AI tools with our classroom teaching to make your lecture very interactive.
Yes.
So what movies or series would you suggest your students or your audience to watch?
Now, movies that my favorite movie is actually Matrix. To be means that Matrix series, I especially suggest that, especially that computer science student that watch that movie Matrix. If you like some horror movie, horror type movie, so just go for Sixth Sense. One very famous movie is there. By Stephen Spielberg. And like series that just recently I watched that series because lots of faculty member discuss about is that is what actually Panchayat.
Panchayat, exactly.
Yeah, so just few days before, even means I have just never watched that series, but due to lots of discussion, so within week I have completed that four series. So definitely these are some good series, but yeah, Matrix, that one is my favorite movie.
So that was an insightful discussion, sir. So moving on to the next segment, 5 minute challenge. So our audience ranges in from curious student to seasonal professionals. So this segment highlights your ability to explain. So complex ideas such as simple, then add expert depth for everyone. So, sir, topic for this segment is AI in agriculture. Sir, as you have said, you will implement quantum computing in this field. Sir, how will you implement it, and how will you explain a non-technical user to this implementation? Actually, sir.
So actually, AI in agriculture is what that agriculture with smart machine. If we want to explain it in one line, so what is AI with agriculture? It's simple. Agriculture activity with smart or intelligent machine. Machine are programmed that are capable to learn. So simply मीन्स हम एग्रीकल्चर करेंगे बट हम इंटेलिजेंट मशीन के साथ में रीजन इज व्हाट सिंपली दैट इट विल हेल्प यू टू एनहांस द yield or that producing capability of your agriculture product. Why smart? It means what? That your machine is able to understand lots of features via that actually we identify the diseases. So we need, means we are just simply going to combine a smart program or machine with your agriculture. That is what actually smart agriculture. Okay. Aim is to enhance the yield. Aim is to uh, reduce the use of your lots of that fertilizers and all that things, pesticide that we use. So that is the simple. Now, term is what that what is the why we are going to connect that quantum computing with machine learning is what? If you heard about that qubits, that actually the core concept of your quantum computing. So here to represent your extracted features, multiple bits are required. But with qubits, with very limited or very small number of bits, you can represent millions of informations. That is the capability of the basic unit of quantum computing that we generally call it qubits. So if a very big informations or feature sets can be represented by very limited number of bits, so automatically optimization of the performance of your processing as well as that recognition of disease, so remaining part will automatically become more efficient. So actually, I'm not going to work on quantum physics, but I am just going to work on that quantum bits and application of that bits to represent your informations, that feature set in a compact way so that remaining process can become very fast. And at the end, if this entire thing can be implemented, so it will become easy to implement at the field level. So that is actually overall idea related to quantum computing, machine learning, and agriculture.
Yes, sir.
Thank you for listening to this season of Beyond Degrees. This was the last episode of season one. It's been an incredible journey exploring ideas that were far beyond the degrees. A special thanks to all our guests and to you, our listeners, making these 5 episodes possible. Stay tuned. We will back with more conversations and we will go beyond degrees. Thank you so much.
Thank you.